Hello and welcome to Global Math Mentor. This is the second lesson on complex numbers from A Level 9709, Pure Mathematics 3. In my previous lesson, I discussed the foundations of complex number, the terms like modulus, argument, conjugate, and Argand diagram. So these were the basics for complex number. This lesson is all about the operations with complex number, like how you can add complex numbers, subtract complex number, multiply complex number, and divide complex numbers, right? And give the answer in Cartesian form. I haven't talked much about the forms right now, but in the later videos, you'll see the forms as well. A complex number can be expressed in many forms, but right now, this is crucial that this form x plus iy is known as a Cartesian form, right? And it's the most common form that we deal with. Okay, this is also important. Make sure you note this one too. For calculation involving multiplications and division, full details of the working should be shown. All right. So make sure you box this one too. Okay. So let's consider an example where I will take two complex numbers and I will show you how to add them, subtract them, multiply them, and divide them. All right. Let's go. Grab on your notebooks. For example, if u is 1 plus 2i and v is 3 minus I, how do you add them? So task 1. Let's do u plus v. If you have studied it before or you have some idea how to add it, you can pause the video and try to add them on your own. Then come back and check my work. Adding complex numbers is very easy. You can just add the real part to the real part and the imaginary part to the imaginary part, whatever the signs operation is. Okay, 1 plus 3, that's a 4. 2 minus I, that's a plus I, iota, right? That's my answer. Task 2. So that's u minus v. Same, you can pause and do it on your own. All right. So if you want to subtract complex numbers, make sure you put a bracket over here. Reason being that this negative outside can change signs. So now simplify it first. X plus 2i, expand the bracket, minus 3 plus I. Okay. So the real part adds to real part. That will be minus 2 with these two. And 2i plus I is going to be a 3i, which is the iota. All right. So that was the first thing. Task 3, how do you multiply complex numbers? Okay, task 3. Let's multiply uv. So if it's 1 plus 2i, and there is an emphasis, you have seen that the examination requirement is that you must show clear working. It's not like you can substitute them in the calculator and get your answer straight away. By the way, in your calculators, if you want to find complex roots, you can go to the setup and go for the option CMPLX complex. That way, if you write an equation with imaginary solutions, the calculator will give you answers with iota. Okay, if you have any problems, you can comment and I'll explain by answering that. All right. So let's do the simple expanding double bracket. So 1 times a 3 is a 3. 1 times a negative I is a negative I. 2 times a 3 is a 6i. And 2 times 2i into minus I. This is important. Be careful. 2i times a negative I is going to be minus 2i squared. So what is iota square? If iota is a square root minus 1, then I square is going to be a minus 1. So 3 minus I plus 6i and plus 2. I hope you get it. Iota square is a minus 1. So minus 2 into minus 1 is a positive 2. So the final answer will be 5 plus a 5 iota. Okay, so far so good. Keep noting down. Task 4. This is by far the little harder than multiplying and adding and subtracting. You'll see why. So if I want to do u over v, that's 1 plus 2I over 3 minus I. And usually the question appears in the exam. They say, write. Okay, let me just write the statement, which is a potential statement in the exam questions. Write u over v as a plus ib. So it means there is a way of dividing complex numbers and writing them as a single complex number. So are you thinking about long division? No, it's not the case, right? Okay, so this is a process known as rationalization, or you can say maybe realize in this case, because you're trying to rationalize the denominator. And basically, you need to remove this I from the denominator. Same thing, if any of you have studied surds before, you know what I'm talking about. Okay, so 1 plus 2I over 3 minus I. Time and divide, listen to me carefully. Time and divide by the conjugate of the denominator. Multiply and divide by the conjugate of the denominator. If you have checked the previous video, you can see that this complex numbers conjugate is 3 plus I. How do you find conjugate? Just change the sign of the imaginary part, right? Okay, let's do the simple multiplication. 1 times 3 is a 3 plus I plus 6I and plus 2I squared, just like the product we did earlier. And in the denominator, hope you're familiar with, I mean, you can expand the double bracket, but know your algebra. There is an identity you've studied before, a minus b times a plus b. In algebra, it's a squared minus b squared. So save your energy and just go straight away for 9 minus I squared. Okay, now I can simplify this fraction. This, is it all right if I make this minus 2? I hope you understand, because iota square is a minus 1. So 3 minus a 2 is a positive 1 plus a 7I divided by, this will be a minus 1. So 9 plus 1, that's going to be 10. In the end, you can write it 1 over 10 plus 7 over 10 I, where 1 over 10 is the real part of this complex number and 7 over 10 is the imaginary part of the complex number. All right, students? So I'll be solving few problems with you where I'll give you some time and you can go over these and then you can check my work. Okay, let's go. Question 1. Add the following complex numbers. The answer should be 4 plus 2, which is a 6, and 3 plus 5, which is 8i. I know they are very simple, but these are the foundational questions. Okay, subtract the complex numbers. So 7 and minus 2, that's a 5. And 6 minus 9, that's a negative 3i. Okay? Okay, next, multiply. So 3 minus 2i plus 12i and minus 8i squared. So I'm trying to do them as quickly as possible. 3, and this will be a positive 8, since iota squared is a negative 1. So 11 plus 10i, right? And the question 4, which is divide. You know how to rationalize the denominator. 2 minus I. This will be time and divide by the conjugate of the denominator. This will be 10 plus 5i plus 6i plus 3 iota square. Divide the whole thing by 4 minus I square. You get it? I'm using the identity difference of two squares. This will be 10 minus a 3, 7 plus 11i over 4 minus a minus 1. That's a positive 5. So 7 over 5 plus 11 over 5 I. That's the answer. And these last two problems as well. So you can see that there is a double bracket like the square bracket as well. So you can do the simple bit mass concept as well. So simplify the expression within the bracket first. 2 plus 3 is a 5. And plus I and a minus 4 is a minus 3I. And there you go. The bracket has been. So when there's more than one bracket, like you simplify the expression within the innermost bracket first and then move on to the outer bracket. So now the final answer needs subtraction. So this will end up 5 minus 1, which is a 4, and minus a 5I, right? And the last problem, first you need to simplify the inner bracket, which is a product of these two complex numbers. So 2 plus 2I minus 3I minus 3I squared. I have simplified the innermost expression first. Keep the 4 minus I outside. 2 and this negative 3 into negative 1 is a positive 3. 5 minus I and plus a 4 minus I. So that's going to be 9 minus 2I. And that's it. In this short video on complex numbers, I just explained the operations with complex number and how you can use these ideas to add, subtract, multiply, and divide complex numbers. The exam questions are obviously harder as compared to this because they test a lot of skills in a single question. So stay tuned. Keep watching for more videos. By the end of this series, I'll solve the past paper exam questions on complex numbers.